All right, guys, today in class we talked about generating equivalent expressions. So previously, the last target that we worked on was when we were identifying if expressions were equivalent. Today we are generating equivalent expressions. So that means we're making our own. And so today we're doing that with the distributive property. So first things first is, what is the distributive property? The distributive property says A parentheses B plus C is equal to AB plus AC. So that's just a bunch of variables, but in other words, that just means we're going to take the factor that's on the outside of the parentheses and we're going to multiply it towards everything on the inside. So if we look here, we're going to take the factor on the outside, which is A, times B, and that's how we get AB. Remember, when we have variables with no operation between them, that means multiplication. So we take A times B, got AB. Then we take A times C, and that's how we get AC. Okay, so we're just taking that factor that's on the outside, and we're multiplying it towards everything on the inside. So let's take a look at some examples. For example, if we have 3 parentheses x plus 2, we can make our own equivalent expression by distributing the 3 to everything inside the parentheses. So we have 3x. 3 times x is 3x. We're going to drop down our addition sign, and then we're going to take 3 times 2, and we get 6. So there's our equivalent expression. So let's check using what we found yesterday to test to see if they're equivalent. So we started with 3 parentheses x plus 2, and we generated our own, which was 3x plus 6. Let's go ahead and let's substitute in 1 to see if they're equivalent on both sides. Okay, so instead of 3x plus 2 in parentheses, we have 3 parentheses 1 plus 2. And instead of 3x plus 6, we're going to take 3 times 1 and then add 6. See if they're equivalent. Now remember, when we're identifying equivalent expressions, we solve each side separately, and then we see if they match at the bottom. So using the order of operations, the first thing we're going to do on our expression to the left is we're going to do our parentheses, which is 1 plus 2, which would give us 3. So now we have 3 times 3. 3 times 3 is 9, and we're done on this side. So let's take a look at this side. On this side, we have multiplication and we have addition. We're going to multiply first, so 3 times 1 is 3. Now we're going to add our 6. 3 plus 6 is 9. Both sides gave us 9. Therefore, we know that we generated an equivalent expression. Okay, so that's just to prove. Today, all we're going to be doing is actually making the expression. This section is just to prove that we did create an equivalent expression. All right, so let's try a few more. Look at this one. It's a little bit different because the factor that is on the outside of the parentheses is at the end, doesn't change anything at all. Okay, we're still going to take 2 times 4x. 2 times 4 is 8, and we have our x, so that's 8x. We're going to drop down our addition sign, and then we're going to take 2 times 8, and 2 times 8 gives us a 16. So our equivalent expression is 8x plus 16. Okay. All right, now let's take a look at this one. The only difference here is there are 3 terms inside of the parentheses, and there are 2 different variables. Absolutely nothing changes. We're just going to have to distribute a few times more. So first off, we're going to take our 4 times 4u. 4 times 4 would give us a 16u, and we're going to drop down that addition sign. Then we have 4 times 5. 4 times 5 would give us a 20, and we're going to drop down our subtraction sign. Then we have 4 times 7y, and we get 28y. So 16u plus 20 minus 28y is our equivalent expression.